Hi students, welcome to Mathologic classes. So today we are going to discuss some previous year questions asked in the CBSE board examination from the topic quadratic equations. It is an interesting topic. We will be starting with some basic questions asked in the previous year questions paper, which involves just the applications of the concepts and the formulae learned. And then slowly we will be increasing the difficulty level of the questions, and in the end we will be dealing with some questions involving 2 or 3 concepts. So let's start with the first question. So the first question is, if the polynomial p of x is given by p of x is equal to x square minus 5x plus 6, then the value of p of 1 plus p of 4 is. So a polynomial is given here, x square minus 5x plus 6, and we have to find out the value of this polynomial at x is equal to 1 and x is equal to 4. So we have to find out p of 1 plus p of 4. So p of 1, how we have got p of 1? By replacing x by 1 on the left hand side. So to get the value of p of 1, we have to replace x by 1 on the right hand side also. So it will be 1 square minus 5 times 1 plus 6 plus p of 4, we will replace x by 4 on the right side. So it will be 4 square minus 5 times 4 plus 6. So 1 plus 6, 7, 7 minus 5, 2, plus 16 plus 6, 22, 22 minus 20 is 2. So 2 plus 2 is 4. So the sum of the values of the polynomial at x is equal to 1 and x is equal to 4 is 4. So our option B will be our answer. So this was a simple application of finding out the values of the polynomial at a given value of the variables. Okay, I hope this would be clear. Now let's move to the next question. The zeros of the quadratic polynomial 2x square minus 3x minus 9 are. So first of all, what are zeros? Zeros are the values of the variable which makes the value of the polynomial 0. It means we have to find out the values of x at which 2x square minus 3x minus 9 turns out to be 0. So one simple way is we can put the values of the options and check at which values it is turning out to be 0. Other way can be we can factorize it and check out the values and find out the values at which the polynomial turns into 0. So to find out the zeros, we will make this polynomial equal to 0. We will equate this polynomial to 0. And then we will split the middle term. So how we split the middle term? We multiply the coefficients of x square and the constant. So that is 2 times minus 9 is minus 18. And the coefficient of x is minus 3. So I have to find out two values whose sum is minus 3 but product is minus 18. So I hope you would have guessed it is minus 6 and plus 3. So minus 6 plus 3 is minus 3 and minus 6 into 3 is minus 18. So we can write minus 3x as minus 6x plus 3x minus 9 is equal to 0. So from this we can take 2x common. So if we take 2x common, so x minus 3 will be there, and from these two we can take 3 common. So x minus 3 will be there. Now from these two, x minus 3 is common. So if we take x minus 3 common, 2x will be left and plus 3 will be left is equal to 0. So x minus 3 and 2x plus 3, these are two terms and their product is 0. So product of two terms will be 0. Product of two terms will be 0 only if at least one of them is 0. At least one of them is 0. If both are non-zero, then product of two non-zero numbers cannot be 0. So either x minus 3 is equal to 0 or 2x plus 3 is equal to 0. Both can be 0, but at least one has to be 0. So this implies that x can be 3, or from here if we shift 3 to the right hand side, it will be minus 3, and then we can divide by 2. So we will be getting x is equal to minus 3 by 2. So either x can be 3 or x can be minus 3 by 2. So first option, x can be 3 or x can be equal to minus 3 by 2. So the zeros of the quadratic polynomial, the question was the zeros of the quadratic polynomial. So we had to find out the values of x at which this polynomial turns into 0. And how we found out? We equated this polynomial to 0. Then we used the concept of splitting the middle term. And then we got this polynomial is the product of x minus 3 and 2x plus 3, and x product of x minus 3 and 2x plus 3 is equal to 0. So product of two terms is 0. It means either at least one of them should be 0. So either x minus 3 is 0 or 2x plus 3 is 0. So from there we got x can be 3 or x can be equal to minus 3 by 2. So the option A is our answer. Now the third question. If the roots of the equation ax square plus bx plus c is equal to 0 and a is not equal to 0 are real and equal, then which of the following relation is true? So this question is just checking that whether you have studied this topic or not, because this is just a formula which they are asking. So if the roots of the equation are real and equal, so we know roots, the nature of roots are found out by discriminant, and we know what is discriminant. Discriminant D is b square minus 4ac. So this is the discriminant, and we know that if this is equal to 0, then roots are real. So if b square minus 4ac is greater than is equal to 0, then roots are real. So you have to be cautious. Here I have put greater than and equal to sign, both. Greater than and equal to sign, both. So here roots are real, but we want real and equal. So roots are real and equal only if b square minus 4ac is equal to 0. So this is the condition for roots to be real and equal. But if we see the options, none of the options matches this condition. So we have to just rearrange something. So from here I can get b square is equal to 4ac. Again we are not getting anything, but if I see option C, if we cross multiply 4, so we will be getting b square is equal to 4ac. Or if we divide by 4 on both the sides, so 4 will cancel out from here. So I will be getting b square by 4 is equal to ac. So option C will be our answer. So I hope this should be clear. So the question was asking what ax square plus bx plus c is equal to 0. For what condition the roots will be real and equal? So we know roots are real and equal if the discriminant is equal to 0, that is b square minus 4ac is equal to 0. So we shifted 4ac on the right hand side, so we got b square is equal to 4ac. But none of the option was matching with this, so we divided by 4 on both the sides, so we saw that option C will be our answer. So moving to the question number 4. The quadratic equation x square plus x plus 1 has dash roots. So we have to find out which option will be here in this blank. X square plus x plus 1 has dash roots, and the options are real and equal, irrational, real and distinct, and not real. Means we have to find out the nature of the roots, and nature of the roots are, we find nature of the roots by finding out discriminant. So I have to find out b square minus 4ac for this. Now what is b? B is the coefficient of x, and here the coefficient of x is, if nothing is there, it means I can write it 1. And here also we can write it 1. So coefficient of x square is denoted by a, and the coefficient of x is denoted by b, and constant term is c. So here we can see b is 1 minus 4, a is 1, and c is also 1. So 1 minus 4 is equal to minus 3. So the discriminant is minus 3, it means it is less than 0. So if discriminant is less than 0, then the roots are not real. We know the roots are not real if the discriminant is less than 0. So it was just the basic application of the concept of the nature of the roots of a quadratic equation. So this would have been easier. We just found out the discriminant, and from the given equation x square plus x plus 1, the coefficient of x was 1, that is b. So 1 square minus 4, a is 1 and c is also 1. So 1 minus 4 is minus 3. Discriminant was less than 0. So we said that the roots are not real. Moving to the question number 5. If the sum of the zeros of the polynomial is root 2, then the value of k will be. So we have to be cautious here. The sum of the zeros we have to find out. And how we write sum of zeros? In a quadratic polynomial, sum of the zero is minus b by a. So minus b by a, where b is the coefficient of x. So here the coefficient of is minus k root 2. So we have to be cautious here. We have to take the coefficient along with the sign. So here it is minus. And minus b. In place of b, it is k root 2. Minus b by a, the coefficient of x square, that is 2. And this is given to be equal to root 2, because sum of the zeros of the polynomial is root 2. So from here, minus and minus will become plus k root 2. So we can write 2 as root 2 times root 2, and here k root 2 is already there. So 1 root 2 will cancel out, is equal to root 2. So from here we got k by root 2. So 1 root 2 will be there, is equal to root 2. If we cross multiply, we will get k is equal to 2. So the value of k will be 2, that is the option B. So if the sum of the zeros of the polynomial was given root 2, so we applied the concept that in a quadratic polynomial, sum of the zeros is given by minus b by a, where b is the coefficient of x, and we took the coefficient along with the sign, that is minus k root 2, and divided by a, that is the coefficient of x square, so that is 2. So minus minus was plus, so k root 2, and 2 was written as root 2 times root 2 is equal to root 2. 1 root 2 got cancelled out, so k by root 2 is equal to root 2. Cross multiplied, we got the value of k is 2. Now moving to the question number 6. If alpha and beta are the zeros of the polynomial kx square minus 30x plus 45k, and it is given that alpha plus beta is equal to alpha beta, then the value of k is. So the options are given. We have to find out the value of k if alpha plus beta is equal to alpha beta. So alpha and beta are what? They are the zeros. Zeros or roots of this polynomial. So sum of the zeros or roots is given by minus b by a, as we saw in the previous question, and b was the coefficient of x. So minus b by a, it means minus 30. Minus b by a, that is k, the coefficient of x square. So this is alpha plus beta, and alpha beta is the product of the roots, and product of the roots is given by c by a, where c is the constant term, that is 45k, the constant term, divided by a, the coefficient of x square, that is k. So from here we can k cancelled out. So minus minus became plus. So 30 by k is equal to 45. So we can shift the denominator of 45 is 1, so we can cross multiply. So 30 is equal to 45k. We can divide by 45 on both the sides, so we will be getting 30 by 45. And we know 30 and 45 can be cancelled out by 15. So 15 2 is 30, 15 3 is 45. So 2 over 3. So the value of k will be 2 over 3. So this was again a simple application of the formula for the sum of the roots and the product of the roots in case of quadratic equation. So we applied that concept. Sum of the roots is minus b by a, product of the roots is c by a. We wrote the values from the equation, simplified it, we got k is equal to 2 by 3. Moving to the question number 7. the ratio of the sum and product of the roots of the quadratic equation 5x square minus 6x plus 21 is equal to 0 is. So we have to find out the ratio of sum and product of the roots of the equation. So what is the sum? Sum is minus b by a, where b is the coefficient of x. So minus b. So it is minus of minus 6 by a, that is 5. And we have to find out ratio. And product is c by a, constant term, divided by the coefficient of x square, that is 21 by 5. Now this is a ratio, so we can multiply or divide by any number to both the numbers. It will be, ratio will remain same. So we can multiply by 5 to both the equations, both the numbers. So 5 will cancel out from the denominator, so minus of minus becomes plus 6 is to 21. So the ratio became 6 is to 21 by multiplying by 5 to both the numbers. But none of the option is matching our answer. So we can check if we can simplify it more. So we can cancel it by 3. 6 is also a multiple of 3 and 21 is also a multiple of 3. So 3 2 is 6, 3 7 is 21. So we got 2 is to 7. So 2 is to 7. Option B is our answer. This was very easy question. We had to just find out the ratio of sum and product of the roots. So we found out sum minus b by a, that is minus of minus 6 by 5, and product 21 by 5. We multiplied by 5. So it became 6 is to 21. We divided both the numbers by 3. So it became 2 is to 7. So option B will be our answer. 8th. If the zeros of the polynomial are reciprocal of each other, then the value of b is. Now this is reciprocal of each other. This is interesting question. Here no real information is given about the roots, but it is just given that they are reciprocal of each other. We don't have any value of the roots. So they are reciprocal of each other, then we have to find out the value of b. Now we have to understand that if the roots are reciprocal of each other, so if I assume that alpha is one of the roots, then next other root will be 1 by alpha, because they are reciprocal, and it is a quadratic equation, then it can have maximum only 2 roots. So their product will become 1. It means roots are reciprocal of each other. It means product of the roots should be 1. And how we get product of the roots? It is constant term divided by the coefficient of x square, means c by a. It means 2a by b divided by a, that is the coefficient of x square. It means 2a by b times 1 by a. We reciprocated it, so a got cancelled out. It means we got 2 by b should be equal to 1, because product of the roots is equal to 1. So if I cross multiply, I will be getting b is equal to 2. So our answer will be option A. What was the question? It was given that zeros of the polynomial are reciprocal of each other. So we inferred that if the zeros are reciprocal of each other, their product will be 1. So if the product of the roots is 1, it means constant term 2a by b divided by coefficient of x square, that is a, should be equal to, that is product of the roots should be equal to 1. So we changed the division into multiplication and reciprocated a. So we got 2 by b should be equal to 1. So b should be equal to 2. Now moving to the question number 9. Now this is also an interesting question. So 8th, 9th and 10th are very interesting questions. 9th one, the zeros of the polynomial. So there are two polynomials given, x square plus px plus q and 4x square minus 5x minus 6. So it is given the zeros of the polynomial of x square plus px plus q are twice the zeros of the polynomial 4x square minus 5x minus 6. It means the zeros of this equation are twice the zeros of this equation, then the value of p is. We have to find out the value of p. If alpha and beta are the zeros of this polynomial, then the zeros of this polynomial will be 2 alpha and 2 beta because they are twice of this. It means sum of, so from here if I find out the roots of this, sum of the roots of this equation, so I will be getting twice of alpha plus beta, and sum of this roots of equation is alpha plus beta. So sum of roots of this equation, that is minus p minus b by a, that is the coefficient of x, that is minus p by a, that is coefficient of x square, that is 1. So minus p will be equal to twice of sum of the roots of this equation, that is minus b, that is minus of minus 5, that is 5 by a, that is 4. So I can cancel 2 and 4. So p minus p is 5 by 2. So p should be equal to minus 5 by 2. So our answer will be option A, that is minus 5. The value of p is minus 5 by 2. So the zeros of the polynomial x square plus px plus q are twice the zeros of the polynomial 4x square minus 5x minus 6. So the value of p is, so inferred that if alpha and beta will be the zeros of this polynomial, then zeros of this polynomial will be 2 alpha and 2 beta. So their sum will also be twice of the sum of the roots of this equation. So we applied that concept and we got minus p is equal to twice of 5 by 4. So p should be equal to minus 5 by 2. Now moving to the last question of today's. It is an interesting question. If x square plus bx plus b has two real and distinct roots, then the value of b can be. So we have to be very cautious here. It is not saying what is the value of b. It is asking what can be the value of b. So there is a possibility what can be the value of b. It means we are not going to get a fixed value of b. We will be getting a range of values of b, and from that range we have to see which option is coming in that range. So that will be our answer. It has two real and distinct roots. So we know a quadratic equation has two real and distinct roots if its discriminant is greater than 0. If its discriminant is greater than 0, then a quadratic equation has two real and distinct roots. And what is discriminant? b square minus 4ac. And what is b? b is the coefficient of x. So b square minus 4a, what is a? Coefficient of x square, that is 1. What is c? c is the constant term, that is b should be greater than 0. That is b square minus 4b should be greater than 0. I can take b common, so b minus 4 should be greater than 0. So product of two terms is greater than 0. So either both should be positive or both should be negative. So from here we can check also which option is satisfying for positive. So if I substitute 0, b is 0, so 0 into something will become 0. So this will not be greater than 0, so A cannot be our answer. If we substitute 4, then b, here if I substitute b is equal to 4, so 4 minus 4 will be 0. Again 0 into anything will be 0, so this will also not be greater than 0. Now if we substitute 3, so sign of b minus 4, that is 3 minus 4 will be negative and this b will be positive. So positive into negative is negative, and negative cannot be greater than 0. So this also cannot be our answer. So option D will be our answer, that is minus 3. So here we completed 10 questions of quadratic equations. These questions were asked in the previous year question papers, and I hope you would have enjoyed this session and learned something new. So in the next lecture we will be discussing arithmetic progressions. So thank you for watching.